Good morning, dear students. A warm welcome to all of you for our today's online session for the subject Science and Technology Section A. We are meeting today for the first time after your first online assessment. Today we are going to start with a very small chapter from your syllabus, chapter number 6 from Physics, Refraction of Light. The topics which will be covered for today are Introduction to Refraction of Light, Laws of Refraction, and the small scale and large scale effects of atmospheric refraction. So let us proceed towards our chapter. For understanding the concept of refraction of light, just remember the topic from physics which you have studied in the last year, chapter number 11 from section A, that is reflection of light. What do you mean by refraction? For this, we are going to take up a very small activity from your textbook itself. The activity is on page number 73. For this activity, you have to take a transparent glass and fill it with water. You can see here in this diagrammatic representation, glass should not be of steel or copper. It should be transparent glass. Dip some portion of a pencil vertically in water. First, you take a pencil, dip the pencil in the glass in the vertical position and observe the thickness of the portion of pencil in water. The part of the pencil which is in water, you have to observe its thickness. Next is, now keep the pencil inclined, means just turn the vertical position to the inclined position of this pencil to the water surface, and now observe the thickness of the pencil in the surface of water or in water. Now in this activity, what you will see? Now you can see here in the first activity, the part of the pencil which is dipped in water. The portion of the pencil which is inside the water, it is thicker, it appears to be thicker than the portion of the pencil which is above the water. It is a very simple activity. You can try this activity at home. You can take a glass or any beaker which is made up of glass material, fill it with water and immerse you can say pencil or a pen in the vertical position, and you will see that the portion of the object which is selected inside the water, it will appear thicker than the portion which is outside the water. In the second case over here, when you will just keep the object in the inclined position, the pencil appears to be broken near the surface of water. So from this activity, what you can infer? So in the first case, portion of the pencil inside the water appears to be thicker than the portion of the pencil above the water. Second case, pencil appears to be broken near the surface of water. So in this activity, the observed effect, it is created due to the change in direction of light while coming out of water. So here we conclude that light changes its direction when going from one transparent medium to the another transparent medium, and this phenomenon is called as refraction of light. So this is the definition for refraction of light. Light changes its direction when going from one transparent medium, now the medium here should be transparent medium, to another transparent medium, which is called as refraction of light. Now this changing of direction of a ray of light, it surely depends upon the velocity of a medium. The change in the direction of a light ray while entering different media is different. Here we will take up a very small example. Just imagine that we are going to visit a seashore. You are running now till you reach the water in the sea. You have to first travel through the ground, then you have to walk through the sand, and then you will reach the water. You have started running. You know that now you are going to visit the seashore and you are going to play in the water. So your speed of running on the ground, from the ground when you enter inside the sand, and from the sand when you enter inside the water, will the speed be same? Surely it will not be same, because you are going to run very fast. Your speed will be very fast on the road, but same yourself when you enter in the sand, your speed will go on decreasing in the sand, and when you enter the water, your speed will be the least in water. You have to balance yourself. Person is same, but media, that is medium, is different. First it is the road, then it is the sand, then the water. So here also the change in the direction of a light ray while entering different media is different. It is related to some concept which we are going to study ahead, which is refractive index. Before that, we are going to see one more activity. For this activity, this we are going to take up as a practical also experiment. Keep a glass slab on a blank paper. This is our glass slab. It is a transparent medium on a blank paper, and draw its outline P, Q, R, S. This is the outline of a glass slab. Imagine this is a plain piece of paper. Draw an inclined straight line on the side PQ. This is your side PQ. You are going to draw an inclined straight line on the side PQ so that it intersects PQ at point N. This is the inclined straight line. Put two pins vertically at 2 points A and B along the line. Here you have to put two pins. Look at the pins A and B from the opposite side of the slab. From the other side of the slab, you are going to look at both the pins, and then put two pins C and D. These are the two pins on the other side of the slab, so that the images of A and B are in a line with points C and D. Now remove the chip and the pins. That glass slab you are going to remove, and the pins, and you are going to draw a straight line going through the points C and D. These are the 2 points C and D, so that it intersects this side SR at point M. Join points M and N. These points you are going to join. Observe the incident ray AN. AN is your incident ray, and the emergent ray MD. One is entering the glass slab and the other is passing out in the air. That is the other media. Transparent medium means what? Air, water, glass. All these are the different transparent media. Now you know the phenomenon of refraction of light. So when will your first refraction occur? Your first refraction will occur when the light ray enters the glass from the air at point N on side PQ. Your first refraction will occur when this ray of light will pass from the air. Now suppose this is the air, first medium, then this light ray is entering into the glass slab, which is the other transparent medium, and intersecting at point N on side PQ. So your first refraction and second refraction, now when it will take place? When the light enters the air through the glass. Now this light ray is coming out in the air from the glass at which point? At point M. On which side? On side SR. Now consider for the first refraction the angle of incidence. Now this is the incident ray. So angle of incidence you will consider as small I, while for the second consider it as small I1. This is I1. The angle of refraction at N, angle of refraction you will take as small r. Now always remember, here you have a tendency, human tendency to create a mistake. you can write angle of reflection, because in the earlier standards you have studied only and only about reflection of light. But now forget, in the 10th standard you have a total, this is a different phenomena, it is refraction. Algebra, maths ka fraction याद रखो, so refraction. Okay, so angle of refraction R, because if you write about reflection, you will lose the marks. Now here one note you have to take, that this angle of incidence I1 is equal to angle of refraction R. So I1 is equal to R. In the second refraction, the angle of diffraction is E. In the first case, angle of refraction is R. In the second case, it is angle E, which is equal to I. So I is equal to E. On both the parallel sides PQ and RS, these are the parallel sides, just recollect about geometry, PQ and side SR of the glass slab, the change in the direction of light ray is equal, but it is in the opposite directions. Thus, the light ray MD, this is the MD emerging from the glass slab into the air, it is parallel to the incident ray AN. So you can see this is the extended ray. This MD which is emerging out from the glass slab, it is parallel to this line AN on the side PQ of the slab. But the emergent ray, if you see, is somewhat displaced with respect to the incident ray. So this is an experiment which you are going to do in the practicals to understand the phenomenon of diffraction of light. Now ahead we go to the next topic, laws of diffraction. In the earlier standards you have studied about laws of reflection. So here let us study about the light ray entering a glass slab from the air. This is the glass slab, one medium. The air is the other medium. So here we are going to consider a light ray entering from the air into the glass slab. Here AN is the incident ray. AN you consider as the incident ray passing from the air into the glass slab, and NB from N to here. NB is the refracted ray. So your first law of refraction states that the incident ray and the refracted ray, they are at the opposite sides of the normal. This is your normal. So incident ray and refracted ray, they are on the opposite sides of the normal at the point of incidence. This is the point of incidence, that is N, to the surface of the slab, and all the three, that is the incident ray, the refracted ray and the normal, are in the same plane. Second law states, for a given pair of media. Now here the given pair of media is A and glass. Now what is the difference between medium and media? When you speak about one, suppose I speak about glass, it is medium. When I speak about more than one medium, it becomes media. We say boy, boys, girl, girls. So medium, more than one, plural form is media. So here for a given pair of media, that is air and glass, the ratio of sin I to sin R is a constant. I is what? The incident ray here. So angle of incident. What is R? R is angle of refraction. So I is the angle of incidence, R is the angle of refraction. So sin I upon sin R is constant, which is denoted by small n, and that n is called as the refractive index of the second medium, that is glass, with respect to the first medium, and this second law is also called as Snell's law. So these are the two laws of refraction which you have to study, you have to remember. Now this can be asked as a direct question in the exam. State the laws of refraction, or a glass slab with this diagrammatic we will be provided to you in the exam. Looking at it, you have to state the laws of refraction, or they can ask about the Snell's law also. So depending upon the question, you should be ready with the answer. Now here I spoke about refractive index. I had told you in the beginning, we are going to study about a new topic, refractive index. So what is this actual refractive index? What is it depends upon? Refractive index, it depends on the velocity, the speed of light in the medium. And this value of refractive index is different for different media and also for light of different colors for the same medium. Even if your medium is same and light is of different colors, then the value of refractive index is different. Now refractive index of some substances are given in the chart on page number 75. You can see here the refractive index of air, ice, water, alcohol, kerosene and different substances are displayed in the chart in your textbook. So you don't have to remember or learn them, only remember a few very normal ones like air, ice, water, alcohol, kerosene. First five you just remember their values. Now let us find out the formula for calculating this refractive index. Now here, I have told you that refractive index depends on the velocity of light in a given medium. So, the velocity of light in first medium we will consider as V1. For the second medium we will consider as V2. Here you can see for the first medium air it is taken as V1. For the second medium glass they have taken the velocity of light as V2. So the refractive index of the second medium with respect to the first medium, refractive index of second medium, refractive index I have told you is denoted by small n type. So of the second medium with respect to the first medium, it is equal to the ratio of velocity of light in medium 1, that is V1, upon velocity of light in medium 2, that is V2. And similarly, the refractive index of medium 1 with respect to medium 2 will be V2 upon V1. So, the refractive index of first medium with respect to the second medium is velocity of light in second medium upon velocity of light in the first medium. If the first medium is vacuum, then the refractive index of medium 2 or the second medium, it is called as absolute refractive index and it is written just as small n. So this formula is important. Both these formulae are important. They should be learnt by you as they are useful ahead for mathematical calculations when you solve the numerical examples for this chapter. Now we are going to study the refraction, the behavior of a ray of light from one media to the other or in different medium. Now here air and glass are taken as the two media. Air is the rarer medium as compared to glass, which is the denser medium. Glass is more dense as compared to air. So the first medium here is rarer, second is denser. Here again glass is the denser, air is the rarer medium. So the first is when a light ray it passes from a rarer medium, that is from the air, to the denser medium, that is glass, it bends towards the normal. This is the normal. On the other hand, when the light ray it passes from the denser medium, that is when the light ray travels from the glass to the air, it moves away, it bends away from the normal. So refraction of light, the phenomenon of change in the direction of light when it travels in different medium. So the first case is when it travels from the rarer to the denser medium, it bends towards the normal. When it travels from the denser medium to the rarer medium, it bends away from the normal. Similarly, when the light ray is incident normally at the boundary between both this media, it does not change its direction and hence it does not get refracted. It does not change its direction of movement. So this is very important question. They can ask you the behavior of ray of light when it travels through different media, and diagrams they will provide to you. You have to give the correct answer or you have to inform about the bending of the light ray. Now the next topic is about atmospheric refraction. Our next topic is atmospheric refraction. What do you mean by this term, atmospheric refraction? Atmospheric refraction means that sunlight, it travels through the atmosphere. So when it is traveling from one media to the other, it will surely change its direction. That change in the direction of light in the atmosphere is called as atmospheric refraction. It has two different types of effects. One is the small scale effects and the other is large scale effects. The first small scale effect of atmospheric refraction is formation of mirage. Formation of mirage, a new word for you. We will just first understand what is mirage. It is nothing but deceptive appearance. Deceptive means what? Deceptive means likely to give a false impression. A person is not standing there, but you will just think as if the person is standing there. So that is known as deceptive appearance of a distant object or objects caused by the bending of light rays. Where you can see this mirage, you can just observe it on a hot summer day in the afternoon. What is this? It is the apparent random wavering of the hot air. You can see over here arising above the heated roads. In the summer season how heated the roads are. So it is just the apparent random wavering of the hot air rising above the heated roads. Now the hot air is lighter than the cool air above it. Hence the refractive index of the hot air is less than the cool air. So this formation of mirage, it is generally observed during the, you can say, summer season. The light rays which are coming from that distant object appear to be coming from the image of the object inside the ground. You can see here in this figure. Their appearance is from slightly inside the ground. A false appearance. So it is called as mirage. Next small scale effect which you see around you is flickering of the objects beyond and above a holy fire. If you have seen the lightning of Holi, you cannot imagine and say observe small minute particles. You can see their movement above the holy fire. Now what is the reason for this flickering of objects, or the objects you see it as they are moving? Here also you can see that the flickering of the object is through a turbulent stream of hot air rising above the holy fire. If you stand near the holy, the air near you is much hotter than the cool air. And same concept you can apply over here. That is, the refractive index of the hot air is less than the cool air. As the physical conditions of the air are not stationary, the apparent position of object fluctuates. I am speaking about the word apparent. What do you mean by apparent? It is the position as seen by the observer at the center of the moving earth. That is the apparent position. Now, when you speak about the large scale effects, the first large scale effect which is due to the atmospheric refraction is about the twinkling of stars in the sky. You have studied in the you can say pre-primary classes about a small poem, Twinkle Twinkle Little Star. Do these stars really twinkle? No. You have studied about stars. They emit their own light and they shine in the sky during the night time. The stars are point sources of light as they are very far away from us. So during the refraction of starlight from the atmosphere, you can see this atmospheric layers. The starlight, as it bends towards the normal, the apparent position of the star is slightly higher than its actual position. This is the real position and this is the apparent position. Again I will tell you, apparent position means what? The position which is being seen by the observer at the center of the moving earth. Now also this apparent position of the star, it is not stationary. Why it is not stationary? It changes slightly because of the movement of the air. You know, air is moving constantly and the changes in the temperature. The atmosphere is not steady. The refractive index of air in a given region, these are different regions, it goes on changing continuously and randomly. When the atmosphere refracts more light towards us, the star is seen bright. When the atmosphere refracts less light towards us, the star is seen dim, and thus due to the changes in the refractive index of the atmosphere, the stars appear twinkling at night. Actually, they do not twinkle, they appear twinkling. Actual position and the position which is seen by the observer. So this is the first large scale effect, and this is due to what? Due to the changes in the refractive index of atmosphere. So when the atmosphere refracts more light, then star appears bright. When the atmosphere refracts less light, the star appears dim, and this due to this movement, due to the change in the refractive index, the stars they appear twinkling. On the same part, if you speak about the planets, stars, planets both are located in the sky, but planets do not twinkle. Now planets, why they do not twinkle? Because the rays of light from a planet, they also pass through the atmosphere of the earth, but they do not twinkle because the first year condition or the reason is that as compared to stars, planets are nearer to the earth, and so a planet can be considered as a collection of a large number of point sources of light. When we spoke about the stars, I have told you that the stars are point sources of light as they are very far away, but planets as compared to stars, they are nearer to the earth, and hence they do not appear as point sources but appear as a collection of point sources. So if the intensity of light from one point source decreases, it increases from the other source, keeping the average intensity same, and hence planets do not twinkle. Suppose there are 60 students in the class. 3-4 rows are there. Some students have studied the topic about atmospheric refraction. Some students have studied about the loss of refraction. So when the teacher asks the question, here there are n number of students. So when I ask about atmospheric refraction, the students who have learned that topic, they are going to answer. When I ask about loss of refraction, then will the students which have studied that topic, they will answer. So the average answering will remain the same. Similar is the application over here, that planets do not twinkle because they are first thing nearer to the earth, and second thing is they are not point sources but they appear as a collection of point sources of light. Third one more we are going to just study is about the concept of atmospheric refraction of sunrise and sunset. Now, advanced sunrise and delayed sunset, this phenomena also can be explained on the basis of atmospheric refraction. The observer on the earth, the observer should see the sun when it reaches the horizon. This is the observer on the earth's surface. When he should see the sun when it reaches the horizon, but it is seen 2 minutes before that. Why? As a ray of light from the sun, means sunlight, when it enters the earth's atmosphere, it follows a curved path due to refraction before reaching a observer. Real position, apparent position at the sunrise, during sunset. When should the observer see? When the sun is at the horizon, but 2 minutes before sunrise the observer can see Similarly, after the sun sets also, 2 minutes after that also observer if you can see it. A very small example if you speak about, after the recess the teacher has entered the class, students have already taken their seats, one or two children are just outside in the corridors, they just want to see, peep inside and see whether the teacher is there. One of the child just peeps from the door. The teacher has immediately seen the child. The child's face can be seen. I have assumed that the child is standing at the position from where I can see, but actually the child is behind, a little 2 or 3 footsteps behind. So why I can see the child? Because the child has bent and peeped inside. So similar application is here. As the sun rays they bend while traveling from one medium to the other medium, you can see that sun not when it reaches the horizon, but 2 minutes before sunrise and 2 minutes after sunset, and hence we can say that advanced sunlight and delayed sunset, it increases the duration of the day by 4 minutes. 2 minutes before sunrise and 2 minutes after sunset. So the total duration of the day is increased by 4 minutes. So these are the 3 large scale effects of atmospheric refraction. One is about the twinkling of the stars. Second concept is why planets do not twinkle. And third is about the atmospheric refraction of sunrise and sunset. With this, we wind up with our today's session. In our next session, we are going to start with a new topic from this chapter, dispersion of light, total and partial internal refraction, and the formation of rainbow. So explanation of the chapter will get completed in our next session, and we will discuss the textual exercise also. So I request all of you, when you attend the next session, keep the textbooks and pencils ready with you. Thank you, dear children.